Assalamualaikum warahmatullahi wabarakatuh. I'm Luffy Ardiansyah. In this video, I will present an ordinary annuity and Unity. I use the book An Introduction to Actuarial Mathematics as a reference. Annuity is classified according to the payment method there are two, namely ordinary annuity and Unity. Annuity is a type of cash flow whose payments occur at a regular time in course. If the payments are made in arrears, that is, at the end of each time period, the annuity is called an ordinary annuity. The on case. Mr. Audi always invested $1 for n month in mutual fund. An annuity is payable monthly in arrears. How much is present value and future value if I, rate of interest, is used? You must know, present value of PV is the value an expected income stream determined as of the date of valuation, and future value of FV is the value of an asset at a specific date. Okay, we make a line period when 0 period 0, 1 period $1, 2 period $1, 3 period $1 until n period $1. So we find AN is geometric sequence. So AN equals 1 times V plus 1 plus V square plus 1 times V cube until 1 times V to the power n. And then we factorize V. So we find V times 1 plus V plus V square plus V cube until V to the power n minus 1. And we define what V equals 1 over 1 plus I. So AN equals 1 over 1 plus I times 1 minus V to the power V over 1 minus V. So we define 1 minus V equals D. So AN 1 minus 1 over 1 plus I times 1 minus V to the power n over D. So D equals I over 1 plus I. So AN equals 1 over 1 plus I times 1 minus V to the power n over I over 1 plus I. And AN equals 1 minus V to the power n over I. So we find present value is PV equals 1 minus V power n over I times A. A is annuity. From the equation above, we can denote the other form of equation is PV equals 1 minus 1 plus I to the power of minus n over I times A. From the equation 1, we denoted how much annuity is A equals I times PV over 1 minus parenthesis 1 plus I cos parenthesis to the power negative n. And from the equation 1, we denoted n periodic n equals I plus 1 logarithm A over A minus I times PV. Future value define Sn equals 1 plus 1 times parenthesis 1 plus I plus parenthesis plus 1 times parenthesis 1 plus I plus parenthesis over 2 plus until 1 times open parenthesis 1 plus I plus parenthesis to the power n minus 1. So Sn is geometric sequence. So Sn equals 1 minus parenthesis 1 plus I plus parenthesis to the power n over 1 minus parenthesis 1 plus I plus parenthesis. So Sn equals 1 minus parenthesis 1 plus I plus parenthesis to the power n over minus I. So and then Sn equals 1 plus I plus parenthesis to the power n minus 1 over I. So we find future value is Fv equals parenthesis 1 plus I plus parenthesis to the power n minus 1 over I times A. From the equation 2, we find annuity is equals I times Fv over parenthesis 1 plus I plus parenthesis to the power n minus 1. And n period equals I plus 1 logarithm A plus I times Fv over A. So you know present value and future value, you can find correlation between future value and present value. Future value equals present value times parenthesis 1 plus I plus parenthesis to the power n. Interest rate. We can find the interest rate in two steps. First, find the value of TP that are greater and lower than the determined TP by entering any value of I into the present value formula of Annuity. Second, after getting an interest rate that obtains the greater and lower PV, use the interpolation as follows: I minus I2 over I1 minus I2 equals PV minus PV2 over PV1 minus PV2, or I minus I2 over I1 minus I2 equals FV minus FV2 over FV1 minus FV2. Next, BTU. If the payments are made in advance, that is, at the beginning of each time interval, the annuity is called an annuity due. We make a line time period because The payments are made in advance, so when zero period is $1, when one period $1, two period $1, until minus $1. So AN AN is factor annuity for annuity 2. AN equals 1 plus V plus V squared plus V cubed until V to the power n minus 1. A equals 1 plus AN minus 1. AN minus 1, this is factor annuity for ordinary annuity. Time on the left side with V and on the right side with V. So V times AN equals V plus V squared plus V cubed plus until V to the power n minus 1. Now, so V plus V squared plus V cubed until V to the power n minus 1. This is same with AN at AN with on ordinary annuity. So AN due annuity equals AN ordinary over V equals 1 minus V power n over IV. The other denote AN due annuity equals 1 minus parenthesis 1 plus I plus parenthesis minus the power minus n over IV. So the present value of annuity due is PV equals 1 minus parenthesis 1 plus I plus parenthesis to the power of negative n over IV times A, or PV equals 1 minus parenthesis 1 plus I plus parenthesis minus n over V times A. From the equation 3, we find annuity is A equals B times PV over 1 minus parenthesis 1 plus I plus parenthesis to the power minus n. And from the equation 3, we find n period is n equals I plus 1 logarithm A over A minus B times PV. From correlation FV and PV, we find FV equals parenthesis 1 plus I plus parenthesis to the power of n minus 1 over I times V times A NVT. Or we find FV equals 1 plus I to the power n minus 1 over V times NVT A. From the equation 4, we find NVT if we know future value. A equals D times FV over parenthesis 1 plus I to the power n minus 1. And we also find n period if we know future value is n equals I plus 1 logarithm D times FV over A plus 1. Next, interest rate. Interest rate on annuity due same with annuity Ordinary. After you know annuity due and annuity ordinary, we find a relation annuity due and annuity ordinary is PV on annuity ordinary equals P times PV annuity due, and FV annuity ordinary equals P times future value annuity due. I give you exercise. You can try this exercise on your own. Thanks for watching.